Stunned by Mars? You're not alone. NASA's Curiosity rover just captured new panoramic images that not only dazzle the eyes, but plunge us straight into one of the planet's greatest scientific mysteries. Yet, here's the twist. These Martian vistas aren't just beautiful. They could rewrite what we think we know about water, life, and even the past climate on the red planet. On an exceptionally clear winter day, Curiosity climbed to a vantage point along the base of Mount Sharp, an awe-inspiring 3-mile-high massif rising from the heart of Gale Crater. From this lofty perch, the rover's cameras gazed across the crater's floor, and right at the center of the images lay the ancient channel known as Vallis. Scientists have long suspected that billions of years ago, Vallis served as a natural highway for water, funneling it into Gale Crater. But here's where it gets controversial. No one can say for certain how these winding Martian valleys took shape, or where the water came from in the first place. The real surprise? Despite Mars and Earth being separated by an average of 140 million miles, Vallis uncannily resembles river systems found on our own planet. Some researchers suggest that rain once fell on Mars, carving out riverbeds when the planet was warmer and wetter. A mind-blowing idea considering Mars is now a frigid desert. Others propose that melting snow or hidden subterranean springs created these channels. The debate is very much alive, with each new image challenging old theories. The latest photographs, snapped nearly 19 miles away, reveal previously unseen formations, rocky outcrops, intriguing layers of sediment, and erosion patterns etched across the barren landscape. NASA highlights that, although Curiosity has imaged Vallis before, this is the first time scientists have been able to observe such detailed features within the valley itself. To create these astonishing panoramas, Curiosity's mastcam captured 44 individual frames. Once back on Earth, scientists meticulously stitched these frames together, using color adjustments so that viewers can see the Martian landscape as it would look to the naked eye on Earth. For closer inspection, the rover's ChemCam, essentially a mini black-and-white telescope, scanned distant formations, piecing together another composite from 10 separate frames. These dark, jagged features hint at secrets waiting to be uncovered. Why does this matter? Because these close-up views could finally help scientists answer burning questions about how sediment moved through Gale Crater, how long water was present, and ultimately, either Mars could have hosted life. For context, Mars wasn't always the cold, dusty wasteland we see today. There is compelling evidence of ancient lakes, rivers, and even global oceans. But exactly when Mars dried up, why its watery era ended, and how long habitable conditions persisted remain topics of fierce debate. Here's a thought-provoking detail. Evidence suggests that water and sediment once flowed down Vallis, spreading out in a vast fan across Gale Crater's basin. Just imagine a landscape, not as bone dry, but as a place where rivers might once have meandered across the surface. Since its launch in 2011, Curiosity has racked up more than 352 million miles, a journey of immense technological achievement, traversing both the space between Earth and Mars and the rugged Martian terrain itself. All this effort is aimed at a grand question. Did Mars ever support microbial life? And if so, for how long? Here's the part most people miss. Excitement about life on Mars is mounting. In a recent press event, NASA announced that Perseverance, Curiosity's younger sibling, had collected a rock sample at Gale Crater with structures that could be fossilized remains of ancient microbial activity. However, they are cautious to note that non-biological processes could also explain these formations. Still, this is the closest scientists have come yet to unlocking Mars' most tantalizing secret. Currently, Curiosity is investigating a curious landscape some 2,000 miles from Perseverance, a region called a boxwork, named for its weird, grid-like pattern of ridges. Scientists theorize these features may have formed as the last trickles of water seeped through the soil before the planet dried out. Or, is it possible that mineral veins in the boxwork tell a different story and that groundwater may have vanished much earlier than thought? This conflict over the timeline is sure to ignite passionate debate within the scientific community. So what do you think? Could Mars have once been teeming with life? Are the valleys and sediments the echo of ancient rivers? Or are we misreading the clues? Where do you stand on the origin of Peace Vallis and the fate of Martian water? Jump in on the discussion. Your thoughts could help unravel one of space exploration's biggest mysteries.